When a junkyard engine makes crazy horsepower in the dyno cell, there's only one thing you can say.
Holy crap! Welcome to Engine Power, where engine tech and real-world dyno numbers go hand in hand. This season has been filled with awesome builds. They include a 292-inch inline six with artificial atmosphere, a stroked small block Chevy with a big blower, a big inch FE, and the list will grow as we continue pumping out these shows for you. This engine is going to receive a totally different approach than the ones we just mentioned. They had a lot of new parts and a pretty big price tag. Now this is a Vortec 5300 LM7 LS engine. It has an iron block, aluminum heads, and it was introduced in 1999. Now this engine is known as the garden variety of the Gen 3s. When introduced, the LM7 produced 270 horsepower and 315 pound-feet of torque. Through its production years, it increased in both the horsepower and torque departments. The final Gen 3 LM7 made 295 horsepower and 335 pound-feet of torque. Now the camshaft is very small. Duration at 50 thousandths lift is 190 on the intake and 191 on the exhaust. Lift at the valve with a 1:7 ratio rocker arm is 466 thousandths and 457 thousandths, and it has a 114-degree lobe separation angle.
This engine was pulled out of a Silverado that met its end with a hard front-end collision. Now, we were told it was a good runner with no known issues. Instead of just cleaning it up and dropping it in a project, wouldn't you want to know its condition, especially if you wanted to run efficiently for any amount of time?
This project is getting the badge name Low Buck Vortec, and it's for a good reason. We're going to tear this engine down, thoroughly clean all the parts, do some block upgrades, and spice up the oiling system, including the oil pump. Then the entire engine is going back together with minimal new parts. Now there's some cool things we're going to show you that will allow us to take this little 325 cubic inch engine to the next level and make it a bracket racer or a little street strip bullet. When this engine was pulled, pretty much everything was left intact. We won't need several parts and pieces like the wiring harness, so it will go first. The factory connectors are easy to remove. Simply press on the retaining tab and pull the connector. Coil packs are an important component to hold on to. They are expensive to replace. Look at there, look at there.
A couple leaves.
Yeah.
Now this was a runner.
Typical looking intake runner. And
well, that's why we're taking it apart and cleaning it. I mean, other than it being dirty, if it ran, it'll run again.
That's right. We're going for power numbers, so we definitely won't need the power robbing accessory drive. Plus, it was a little damaged during the collision. Now there are several components that make it up. They range from the water pump, power steering pump, AC compressor, idler and tensioner pulleys, the alternator, and balancer. The exhaust manifolds are cast iron. We will be using a set of dyno headers later, so these go in the scrap bin.
This now gives us a good look at the outside of the engine, and I must say it's definitely had some issues leaking around the seams. But that really doesn't bother us because it's easy to fix oil leaks on an LS because the way the gaskets are designed. There is some truth to the saying, it's all in the pan. Will there be bearing material, foreign matter, or even heavy sludge due to lack of oil changes? We're gonna find out right now. Well, for as many miles as they say it's on it.
Typical LS pan?
Typical LS, there's some little chunky.
Just build up down here, just like in the corners of the pan, like typical.
Yeah, but I mean.
You can tell they weren't very religious on changing the oil.
Right.
But they knew when they got 2,000, 3,000, 4,000 miles over, it was ready. We'll clean and reuse.
Absolutely. So far, so okay. Any high mileage, well-used engine is gonna be a little dirty. You can never really tell what's going on until you tear into it.
Man, see the corrosion down in here? And that one looks brand new. That's what makes these covers hard to get off and usually rip that seal.
Ugh. There we go.
That one came out with that ripping, but look, the one that looked good, ripped off.
The one that looked good ripped, yep. For the sake of your spark plugs and your engine, always loosen the spark plugs by hand before power tools go on them. The valve train looks decent until we take a look at the push rods. The one on the right is in great shape, but the one on the left reveals a heavy wear pattern with lots of metal worn off the ball end. The wear pattern is even more pronounced on the rocker.
All right, let's see what happens over here. Yep, same thing, one.
Man.
Right there.
Okay, this is the exact reason why you tear an engine apart very slowly and look at everything, because this will tell you that you have an issue.
The cylinder head bolts tell a story as well. They are a little on the loose side, which makes us think this engine may have gotten overheated at one point.
Oh,
look at that, there's no
now
breakaway.
Yeah, there's no breakaway on that. How about that? That was running. Or was it?
Or was it?
See,
that's you never know.
You never know if you're getting the truth.
All right. There is still quite a bit of cross-hatching on the cylinder walls. That's a good sign that this engine was taken care of to some point. As we dig into this Vortec, we keep getting hit in the face by the smell of old burnt oil. Like any high mileage engine, this one has its wear and tear. Whether or not this was a runner, we're certainly gonna make it one. Up next, with just a couple of hand tools and a little bit of time, your engine can run its best. We'll show you how. Why is it important to balance your engine? The answer is in today's tech tip.
Balancing an engine minimizes vibration, helping the engine run smoother, maximizing engine life. Balancing requires offsetting the weight of pistons and rods by adding or removing weight from the crankshaft. An engine can be balanced internally, externally, or a combination of both. An internally balanced engine only has modifications to the crankshaft. External parts like a balancer and flex plate flywheel have a neutral balance, so they won't affect other rotating parts. If the crank's counterweights are too light, the engine must be externally balanced. This involves adding weight to the harmonic balancer and or flex plate or flywheel. Generally speaking, internal balance is the better option. External counterweights can cause the crankshaft to flex at high RPMs, which can cause engine damage. However, either type of balance is fine for most engines.
We're continuing on the teardown of the 5.3-liter Vortec. It's looking pretty good, for the most part like a decent running, high mileage engine. A lot of this stuff looks kind of nasty, but it will clean up, I think, okay. Nicely done. Oh yeah, that bearing looks good.
Or not.
Way to go, Pat. Sorry about that. It's crucial to label parts as you're disassembling any engine. Everything needs to go back exactly where it came from. This is what I'm very interested in seeing.
Yes, this is the go-to moment.
Dude, look at that.
What the heck? High mileage LS and the bearings look new.
Wow.
There's still a little bit of coating on the skirt, anti-wear protection in that.
That's unbelievable. And the bearing still has a little bit of crush. So we got a winner. Some places it really looks like an engine with 100,000 plus miles, like the groove behind the main bearing. A thorough cleaning in the jet washer will knock off years worth of grime. We'll run ours at 150 degrees for an hour or so. With all the heavy stuff removed, we'll sand all the gasket surfaces with 180 grit sandpaper. We're just cleaning the surface, not removing material. On the deck, we'll use a flat, long bar to sand evenly across the entire surface. Keeping with the budget theme, we are just going to ball hone the cylinders. This hone is 320 grit for going easy on the cylinder finish. First, lube the cylinders with some 10W30 and get going. We'll do roughly 20 strokes per cylinder, making sure not to stop in one place while the drill is running. Keep the drill at moderate speed and try to achieve around a 40-degree crosshatch angle. Now we're left with a reconditioned surface that should help seal up our ring package.
We just finished washing the oil pump that came out of our budget 5.3, so now it's time to do some budget tech on the pump itself. Now these steps are going to improve the pump's lubrication, pressure, as well as the longevity, even though it's a used pump. Now the first thing we're going to do is go inside the housing and remove the sharp edges where the oil flows on the inlet and outlet side, being careful not to touch the area where the O-ring seals for the pickup. We'll also take the G-rotor gears and dimple every single one of the lobes. Now this will create a pocket of oil between the gear and the actual thrust plate. Last, we're going to shim the spring to increase the pressure about 78 to 82 thousandths. Let's get started. We'll start with a die grinder with a carbide burr. The goal is to smooth out any sharp transitions in the casting. Go slowly and use a light touch. We're just softening the edges, and a heavy hand can do big damage fast. Next, we'll drop on a cartridge roll to smooth everything out. Now we have an OEM pump that flows more like an aftermarket one. The only cost was a few tools and a little bit of time. To dimple the G-rotors, we'll start with a center punch to help guide the drill bit. Then we'll use a 3/16 bit to make the first pass, followed by a 1/4 inch bit. So now that we have the gear dimpled, we're going to go ahead and sand it down because you don't want any of the high spots to catch the front of the thrust plate. So with a little flat surface, some sandpaper, and a little penetrating oil, we'll knock the edges right off. Now I'll go ahead and keep sanding this with the 500 grit sandpaper until the center stays black and quits coming off with the gray. That way we know the edge is knocked off. Looks good. Use plenty of assembly grease when rebuilding the oil pump. Once the G-rotors are in place and lubricated, secure the cover and use Permatex blue Threadlocker on the fasteners. We like the gel formula because it stays in place on the threads.
The bypass and spring drop back into place. We'll use a couple of washers to shim the spring. This will increase the spring tension, which will hold the bypass closed longer, therefore increasing the oil pressure in the pump. Coming up, the Vortec gets buttoned up, then beat on in the dyno cell.
The whole premise of this motor is to see how much power we can make even with a power adder. But one of the things you want to do is take it apart like we've been doing. Now here's one little step, and to us it's kind of one of the most important, especially if you're going to add a blower or nitrous or even turbos, and that is ring gap. So what we're going to do is we're going to remove the top and second ring, place them in the bores individually, and see what they gap at. Right now, just out of the engine, our biggest gap is 30 thousandths on the top and second, so we're going to try to get everything to meet that spec.
Simply place the ring into the cylinder and use the ring squaring tool. Then measure the gap. Out of all of the rings, we only had one gap that was tighter than 30 thousandths. Check it now.
Is that irometer or was that?
That was, no, well, I have a gauge here, but you said 5, so I went dead on 5 here.
There's a 30. Ready? Nice 30.
Imagine that. Next up, the crank gets a light polish with our Goodson crankshaft polishing tool. Both the main and rod journals are in fantastic shape. We didn't use a gridded belt at all, just the cork belt. The result? A smooth, shiny, clean surface. We'll give the engine another pass in the jet washer and begin assembly. One of the few new parts we're installing on this engine is a set of main bearings. The cost is under $80, and since the old bearings look kind of rough, it was well worth the expense. As always, we'll check main bearing clearance for all of the bearings. It varied between 20 and 22 10,000ths. Excellent. Before installing the rod and piston assemblies, lube the cylinders with break-in oil. We'll also lube the wrist pins as well as the rings. Using a ring compressor, they are gently tapped into place. The fasteners are torqued to 15 pound-feet, then 85 degrees on our Matco half-inch drive digital torque and angle meter. We wanted to do something a little bit different on the paint job, and we think this color does the trick nicely. It's Detroit Diesel Alpine Green. We replaced the stock cam with a Cam Motion LS1 Stage 3 hydraulic roller. This is a mild performance cam that still works with stock components. The oil pump is shimmed in 3 places on the gear using 1.5 thousandths shims. This ensures proper alignment when tightened down. Since the stock valley plate was in really bad shape, we decided to use an ICT valley plate instead. The cylinder heads were installed with new stock torque-to-yield fasteners and torqued to 22 pound-feet initially. Then we used a torque angle meter to tighten the fasteners 2 rounds of 90 degrees. Finishing out the build is the valve train, oil pan, and one more aftermarket piece, a Holley dual plane intake manifold. Any experienced welder knows that surface prep is the foundation for a great weld. Forney Industries makes that job easier with a full line of abrasives for welding and bodywork. Their 2-inch and 3-inch surface prep pads fit easily into tight spaces, and they are the perfect size for stripping and cleaning just the right amount of material to lay down a clean bead. The pads are available in coarse, medium, and fine finishes, and they attach to Forney's roll-lock backing pad for secure fit and quick changes. From cutting and grinding to sanding and buffing, there are literally hundreds of products to choose from. Visit ForneyIND.com to learn more. RockAuto.com's slogan is, all the parts your car will ever need. Their inventory is impressive and so are their prices. Plus, they have a selection of wholesaler closeout parts with even deeper discounts. To see these parts, simply choose your vehicle, then click on the orange RSS button next to your car's engine size. Then look in the upper right-hand corner and click the RSS button next to Love a Bargain. Now you can browse a list of wholesaler closeout parts available for your vehicle. The closeout price is limited to stock on hand, so be sure to check out rockauto.com.
Up next, sometimes the engine does what you think it will in the dyno cell, but sometimes,
Oh,
I saw some big numbers, dude.
we're almost ready to fire up the Vortec, but first we need to install some electronic components. We're using a selection of sensors from Duralast. They offer thousands of OEM quality or better parts for almost any vehicle on the road today. Duralast products are rigorously tested for performance and reliability, and they are a top choice of professional auto shops. First is the coolant temperature sensor, followed by the cam sensor. Depending on your application, the cam sensor can be in the front or the back of the engine. Finishing out is a 24-tooth reluctor crank sensor. All right, on our budget extravaganza here, this engine requires 0 break-in, so go from 3 to 6 and make a hit.
Here we go.
Look at that. That is used rings, used rod bearings, used rod bolts, 337 horse.
351 pound-feet of torque.
Nice. You know,
Bone stock heads.
bone stock. I mean, it doesn't get any.
Dual plane manifold.
This is the cheapest you can get one of these things running, right?
Yep.
You can put injection on it, but you have much more sensors, much more wiring, much more messing around with it. This is as cheap as you can get this thing going.
$346 at 6,000.
Yep, 355. See how it's trying to tail off now?
Yeah, oh yeah, definitely. And 200 RPMs, it drops 6. So now here's the thing. We did this to show everybody how they could get a junkyard engine, do a little tech to it, and put a power adder on.
Right. Again, I guess the power adder is nitrous, and again, you know how I am a naturally aspirated guy. This is a good way to do it, though. It really is, because this is the cheapest you can do it to make the most power you can, bang for the buck. So
Yeah.
stick that plate on.
Let's do it.
We're running a Holley Sniper nitrous system, which has a range of 150 to 250 horsepower, depending on the size of the jet.
So 63 jets on fuel and nitrous.
Yep, this
150 shot.
150, okay.
Sniper kit. 3 to 6,000.
600 a second.
It is.
All right, I'm arming it.
All right. Here we
ready?
go.
All right. Whoa.
I saw some big numbers, dude.
No, wait a minute.
Holy
Sorry.
crap!
Oh.
724 pound-feet of torque, 564 horsepower for 150 shot.
All right.
This thing made 347 NA.
217 horse.
God bless!
that's-
Look at the torque.
That's the right jet?
63. I triple checked them.
Wow.
Yep.
724 pound-feet of torque. Now, it was probably higher because we loaded it. Okay. Oh my God.
Oh yeah, it definitely was higher because we loaded it, the brake caught it, brought it down a hair, and then it took off.
So on our 150,000 mile, we reused pretty much everything engine. I think we flirted with disaster right there,
But we won.
We won it. This time we won. All right.
Nice.
Nice job.
Nice.
We made a lot of horsepower, but we didn't spend a lot of money. The engine was $500. A set of main bearings was $80. Cam, lifters, and timing chain were $650. The valley cover was $40. The intake manifold ran us $300. The gasket set, $210. Push rods were $30. 5 rocker arms for $90. Finally, the nitrous kit was $570. A total of $2,470. That's $4.38 per horsepower and $3.41 per pound-foot of torque. Very impressive. For more information on anything you've seen today, visit PowerNationTV.com.